In this tutorial, we are going to go over an introduction to the PBMSECT Web App. My name is Christian Aparicio, and I'll be going through today's tutorial. This is what we want to do in this tutorial. We want to take this existing arbitrary bin cross-section, and we want to modify it slightly, as you can see here on this slide. We want to extend this portion of the cross-section. Now, to define arbitrary bin cross-sections, or ABCS for MSC Nastran, we have to either use the PBMSECT or the PBRSECT entry that is available through MSC Nastran. So in this tutorial, I'm going to show you how to set these two entries for MSC Nastran. So let me go ahead and exit my PowerPoint and let me jump to the Sol 200 web app. What we want to open now is the PBMSECT Web App. The PBMSECT Web App, again, is used to generate both the PBMSECT and the PBRSECT entries for MSC Nastran. So here's the tool, the PBMSECT Web App. Here in this middle column, there's a section where you can access demonstrations. So here we'll click on Demo 1, which is the ABCS or the arbitrary bin cross-section that we are focused on today. So let me turn off the labels. Let me turn off MSC Nastran's interpretation of the arbitrary bin cross-section. And let me turn off this preview. Let me go ahead and jump into the ZY view of this cross-section. So this is the existing arbitrary bin cross-section, or ABCS. Here on the left are the corresponding Nastran entries to define this arbitrary bin cross-section. Here we have the PBMSECT entry, the point entries, and the set1 entries. All of these entries are necessary to define this ABCS. Now, what if we want to extend this part of the ABCS? To do this, we do it as follows. Let's go ahead and create points. Let's go ahead and resize the grid. And now here in this far right hand side of the cross section, we're going to define a few points. Now, when you click and create these 5 points, it's not important that you exactly place them in these 5 positions, but you should come close to replicating what I have here on the screen. After you've created your points, now it's time to connect those points to create your lines. So here, let's go ahead and click Create Lines, and let's zoom in, and we're going to create these lines that you see here on the screen. And then we're going to head and finish these few lines. And then every time you create a point, well, here it's not showing you, it'll show up in a moment. Every time you create a point, you create an internal point bulk data entry. Every time you define a line, you're creating a set1 entry. So I'll show you what that looks like in a moment. One very important thing to do, let me go ahead and click Select Lines of Outer Perimeter. When you're defining these arbitrary bin cross-sections for Nastran with the PBMSECT or the PBRSECT entry, one firm requirement is that you define the outer perimeter. Which of these lines constitute the outer perimeter? Here, for this open profile cross-section, if it was closed, maybe these 2 points would be connected, but since they're open, you just have these lines go like this. They're not connected at the ends. So this is an open profile section. One requirement for open profile sections is that the outer perimeter in blue should go through the so-called orange critical points. So here you see that the blue lines, the outer perimeter lines, are going through these orange critical points. So here at the bottom you see the blue line, the outer perimeter lines are going through the orange critical points. And if you go through the rest of the lines, that is the case. But here, that is not the case. So we're going to click this pink line. After we click it, it's now an outer perimeter line. If I turn on the labels, this line is line 21, line 32, and 33. If I go all the way down to line 21, the type column is now out P for outer perimeter. If I look at lines 32 and 33, these are branch type lines, but the outer perimeter should always go through the orange critical point. So we're going to continue the process and select these other lines. So if we look back at the labels, this is line 22 and 23. If we look back here, lines 22 and 23 are now part of the outer perimeter. If I go back to the bulk data entries, I have a few additional points. So point 1 or 10,021 is the new point. So that is here. So here 21, 22, and 23. So these 3 points are some of the newest points I've created. Points 32 and 33 are some additional points that have been created for this arbitrary bin cross section. If you notice, the set 1 is now a little longer. It has additional points. Set 1 100, this is defining the outer perimeter. So here, if you look at the bulk data entry, out P is equal to 100, where the 100 is the set 1 100. So these are all the points that are part of the outer perimeter. So you can imagine point 23 is right here. Point 22 is the previous point. Point 21 is the next previous point. And then if you go in reverse, you'll find that all the blue lines are going through all these points until the very first point, which is going to be point 10,000, which if you look at the first point on the set 1, this is point 10,000. So now we've created what a so-called preview version of the ABCS. Now, what does MSC Nastran think the arbitrary bin cross-section looks like? Here we're going to run MSC Nastran for these bulk data entries. After the run is complete, here on the left side, we get what MSC Nastran recognizes as the arbitrary bin cross-section. If we go into the ZY preview, here on the left, again, is the MSC Nastran recognized cross-section. And here on the right is what we intended the final cross-section to look like. So it's very important to do this comparison because MSC Nastran sometimes will interpret these entries a little differently from how we interpret it. So it's very important to do this comparison. Now, to prove my point, let me go ahead and zoom in a little. And maybe, let me turn on preview. Maybe I want to adjust the thickness of the walls of this cross-section. How do I do that? So you can either specify a different default thickness, like I'm doing here in this input box, or you can look at specific lines like lines 23 and 22. 23 and 22 would be right here. And then in this thickness column, you can say, okay, I want the thickness to be 0.4 here and the thickness to be 0.3. So this is what we want. We want these two different line segments to be of different thicknesses. So now, like I mentioned before, what does Nastran recognize the cross-section to be? So we'll go ahead and run MSC Nastran. And I expect there to be a slight difference in the cross-section. So here, we do notice a difference. Here, we get a continuous thickness for line 22, and then a continuous thickness for line 23. But if we look at how MSC Nastran interprets these bulk data entries, you'll see that for line 23, we get a continuous thickness. For line 22, we get a continuous thickness, but then suddenly we get this tapering of the thickness. So this is due to the internal algorithm of MSC Nastran. Maybe your cross-section would never use a thickness like this, but here I'm demonstrating why it's important to look at the final cross-section that MSC Nastran has generated for itself, just to make sure that what MSC Nastran is using is what you want. Now, let me go back to the PowerPoint and mention one last thing. So this workshop, if you ever want to access it, is available in the user's guide of the Soul200 web app. If you go to the tutorials section and the Beams tutorials, this would be the first tutorial available, the introduction to the PBMSECT Web App. If you click on the link here, you jump to the tutorial. So that would be this one that you see here on the screen. What I want to show you is the last part of this, well, in your case would be a PDF file. When you first try to use the PBMSECT entry, it might be a little difficult to set up that entry, but the PDF file towards the end has some guidelines that will help you construct the arbitrary beam cross-section. I recommend going through these guidelines to make sure you are prepared to build these arbitrary beam cross-section. And the last thing I'll leave you off with, if you want to look at different arbitrary beam cross-sections, you can do that here by flipping through the various examples or demonstration cross-sections that you see here on the screen. Included are even some composite laminate arbitrary beam cross-sections. Here we look at the walls. The walls are actually composed of different layers of composite materials. And then here at the end, I'll end off with this cross-section. So that's the first tutorial. Thank you so much for watching.